Hi, and welcome back to VM End-to-End, a show where we have a VM enthusiast and a VM skeptic, or former VM skeptic, hash out all things VMs. If you remember the show from last season, we talked about reliability, automation, cost, and all of the benefits that you can get from cloud-native VMs. But there's still some things I'm confused on, so I brought Brian back in to talk about it. Brian, hi. I need to know why I can't have just one giant super machine that just works instead of all these little flimsy parts.
That would be amazing, wouldn't it? You know, just kind of an infinitely large machine. But that is not a thing. And, you know, this season we're going to bring some guests in to kind of dig deeper into some of these concepts. So to tell us, you know, kind of more about why that isn't a thing and how to get reliability out of things, we brought in Steve McGhee. Hey, Steve.
Hey, guys. How's it going?
Hi, Steve. Glad to have you here. Can you tell us a little bit about yourself and who you are?
Sure. I'm Steve McGhee. I was an SRE in Google for about 10 years, and then I left, and I became a customer of cloud, and I learned how to cloud and how to use all the different clouds and just how difficult it is actually to kind of make decisions and you know, stuff like that. And then I came back to Google to help more customers do exactly that. I tend to focus on reliability because my background was in site reliability engineering.
See, this is great because something I'm trying to figure out is people that are focused on reliability, you would think that, or at least I would think that, and Brian has said that I might be a little misguided here, that just having one piece of hardware that you upgrade and put a lot of resources into is going to be a lot more reliable than having lots of smaller parts that have to communicate, that can all fail. So where am I going wrong here?
Yeah, I mean, your intent is correct. Like, it would be sweet if we just had like a perfectly, you know, infinitely dense, infinitely fast computer. You know, when you work on a system on your laptop, you know, the whole phrase, you know, it works on my machine. Mm-hmm. Like, what's the problem? When we go into production, we're scaling up, and we have to scale up because we don't want to like have a service for like one person. We hopefully want it for like many people, right? Potentially even around the world or something like that. So being able to scale up into production means that we run into like actual laws of physics. So, you know, speed of light comes into play, like density of material. Like, you can't go so dense that everything catches fire, for example. That would be bad. And so that means we have to start spreading things out. What it really means is that we're taking what was one computer and we're spreading it across sort of time and space, and we're using many computers instead. So I hope that kind of helps understand like what the basic problem is here.
It really does, because we talked about this a lot. Brian hammered home a point last season. He said a cloud VM is a slice of a data center more so than it was a slice of one specific machine. And so it seems like that's playing out here. But what I don't understand is Google touts its reliability and being able to be up for a long time. But how is it able to do that with so many parts that are constantly going to fail, like a disk?
If you think about like what it used to be like during like the .com boom, we used to call these like gold-plated servers. Like we would make like the most expensive solid server that you could ever have, like many NICs and many power supplies and many everythings and like hot swappable this and that, and those were pretty awesome. Like they lasted really, really well, but they were super expensive. And it turns out that just kind of putting all your eggs into the basket of like making the one machine really reliable only gets you a little bit of the kind of the return, because you still have to have some downtime for like maintenance and scaling up and things like that. And so what we found inside of Google is that we actually wanted to horizontally scale, which is like adding more machines at a time in order to like, you know, achieve, you know, planet-wide scale, like have billions of users, for example. You can't fit billions of users on one very expensive machine. So once you start horizontally scaling, using the most expensive machine possible with very little, like, you know, with marginal return doesn't really make sense. And so this is where we introduced, instead of having like a really solid base, we introduced resilience at many layers in the stack. And it turns out that is way better for the service. It's more economical, and it actually allows you to move faster, which sounds crazy, but it's true.
This shows up in a lot of places in Google Cloud, like around the VMs. You know, like the VMs themselves, you know, are kind of insulated, you know, to some degree from the underlying systems through live migration. We've got different zones of separation between them. We got kind of load balancers, so you can kind of hit different pieces. But it feels like there's like a core principle here or two. I don't know if you could talk a little bit more about that.
Yeah, I mean, so I was I went to school in computer science, so I consider myself like a computer scientist, I guess, or a software engineer. And like, I think everyone who's super into computer science knows like the one holy thing is like layers of abstraction, right? Abstraction solves everything. So really, this is what we're talking about here, is we're going to have many layers of abstraction. And I kind of jokingly refer to this as like the Matryoshka doll, which is like those little nesting dolls you've seen, where you have like, at the very middle, the tiny little doll is like your CPU. And then it goes up to like a machine, and that has a VM around it, and then like that's in a rack, and like it's in a data center, and then the data center is part of a zone, which is then part of a region. And so at every layer of this stack, if you're able to kind of perform some resilience engineering to make sure that you can take advantage of that sort of layer of the stack, this is where you get really it's like defense in depth, right? So you're able to handle failures at any level of this stack, because disks fail, CPUs can go out, you can get solar flares can cause memory corruption, you can have someone can cut a fiber line to a data center, right? And the whole building could potentially go offline. We have floods happen. I mean, they're rare. Fires happen. They're rare too. So there's lots of potential failure modes that you have to consider, and they happen at many of these levels. So being aware of all those and having mitigations ready for them is super important.
It's funny, we're calling it like virtual machines in the cloud, but it's really virtual machines and virtual disks and virtual load balancers. And
that's right. I really liked what you said in the previous episode, that you're getting like a slice of a data center, because we're able to take all these component parts and like present them to a customer as like this nice abstraction. Like, it's this computer with this disk, and it has this network. And in actuality, it might be like the one disk you have is actually 3 disks. But, we're not really showing you all 3 disks. It's just like magically kind of giving it, this resilience and redundancy to you.
Yeah, I see how being able to abstract away the layer underneath yourself and says, I don't care exactly which zone is under this region, as long as one of them is up, I'm fine. That actually makes sense. And it makes sense why we wouldn't want one supercomputer, because it'd be hard to do that. But then now you have to start managing all these separate zones and VMs and all this extra complexity that comes in, which is one of the downsides of abstraction sometimes. How does Google handle that?
A good question. I work with a lot of companies that ask exactly this. They say like, great, you want us to spread all of our computers around the planet? That doesn't sound like a pain in the butt at all. It
Right.
sounds like, well, how in the heck do you expect me to deal with that? And again, the answer comes back to abstraction, right? So when you think about it, like you have, one VM, and it's like the first step you're going to get is, many VMs, right? So we put these together and we put them behind a load balancer. We call this a service. If you're familiar with Kubernetes, it's pretty much the same idea, where you have a bunch of VMs and you have like an entry point that talks to all of them. Mm-hmm. If you can then take this service and you can run it across multiple zones, we can call this a regional service, because it now lives across many of these zones in one region. And then if you can get that regional service in many regions, I call this a distributed service. There's no canonical name for that right now, but like the idea is that it's many of these services, but they all kind of do the same thing, and they represent the same business need. And so you're able to now handle like regional level events as well.
Okay. I'm putting all this together. I'm trying to like really piece this together, because it's still hard to me to think like these things can go down so often, and that gives you more reliability because you're layering them on top of each other. Maybe Brian, you're always good at giving me concrete examples. Is there where do we use this in Google Cloud?
so I think the most common example is when you have multiple VMs that are kind of doing the same job. Maybe they're a web server or something like that, and you put a load balancer in front of them, and like this shows up in physical, installations, and it shows up in the cloud. It's maybe the most common example of this. So you have like one endpoint, and you have multiple different backends that can do the work. Mm-hmm. And if one of them goes away, the work still happens. So I think that's like my favorite kind of specific example. But like, Steve, is there like a more general principle at work here?
Yeah, totally. So an analogy to think about is just think about boats in the water, right? Like physical boats. If you poke a hole in the bottom of your dinghy, like you're going to have a bad day, right?
Yes.
Like that's no good. So we call this one failure domain. Your little dinghy is a failure domain because there's only one like floor to it, right? And if you put a hole anywhere in that floor, it's going to flood. It's not great. But then now think of a bigger ship. Think of like a container ship or some giant, like vessel of some kind. They're kind of like a bunch of little boats tied together because they have these things called bulkheads. So you can, I wouldn't do this, but like you could poke a hole in the bottom of like one hole in the bottom of one of these big ships and it would be fine because what it would do is it would fill up that bulkhead, but the rest of the boat is so buoyant that it stays floating. So essentially like you're taking these things that could fail with a hole and you stick them together. And now the system as a whole doesn't fail with that same failure mode.
Right. So that's exactly what's going on with our VMs and load balancer kind of thing. How do we decide, how does this work? Like how do we, so if you've got VMs and load balancers and these different bits and you mentioned, zones and regions and like just, distributed services, how do we reason about this? Like, how do we decide, how much complexity we're going to kind of put into this?
A good question. Like, that was kind of like the abstract academic answer. And so now, like, let's talk about like reality, Steve. This is an important thing to understand, like what a level of availability you can expect from the systems you're building on top of. Like, how often do we get a hole in the bottom of a boat? Like can we get a number? That would be nice. Mm-hmm. The way that we suggest people think about it is that for something that lives in one zone, we say it's going to be available 99.9% of the time. Specifically, we say it's designed to be available 99.9% of the time. That is basically, it means it's going to be down or unavailable for 40 minutes a month. And it's important to think that's not like the best case scenario or the worst case scenario. Like that's something you can pretty much count on. So it's pretty much going to happen. Similarly, if you have something that is across many zones in a region, we call that 4 nines. It's 99.99% available. And the way to think about that is it's 40 minutes a year of downtime, which is actually pretty good. Like computers stay up quite a lot. 40 minutes in an entire year it's a tiny, we know exactly how big of a fraction it is, but sometimes maybe that's still not acceptable for you. But it's up to like what it is that you're putting on these computers. Like, are you okay with those 3 nines or those 4 nines? And you have to make a decision on what's appropriate for you.
I get this now because basically you're saying, okay, I have 2 computers that are up 40 minutes. They're only down 40 minutes every year. If we layer them over each other, when one's down, the other one's not down, we're good. And so it's just interesting seeing like all of this that comes in that you have to manage on your own. Like, I wonder if I have to come in as the developer and be like, okay, I have to schedule this computer to be up, watching for the other one to be down. Or is this something that the infrastructure can start to take care of for you?
Yeah, the good news is that like this is a problem that inside of Google for the past 20 years we've been dealing with, and so we've come up with a bunch of solutions, basically a bunch of like improvements to the system, and we're bringing those to cloud customers. And so, for example, like we know that sometimes you have to power down a rack of machines or something like that, and like if your computer is on that, if your server is on that rack, like what do you do? Like that's a real bummer. Like should we tell you ahead of time or something like that? But we instead built this thing called live migration, which basically takes like the soul of your machine, like the running system, the running software, and like it transports it magically across the room or whatever to another machine. And that way we can safely power down this rack, bring it back up again. Maybe we had to like replace a fuse or something. I'm not really sure. And basically it's one less thing for you to worry about. And when I said before that machines are designed to have 99.9% of availability, it accounts for stuff like this. So this is how we're giving you 99.9% availability. There's a bunch of other stuff too. Like sometimes the building we need to do maintenance on, or maybe the machine itself has a problem, or who knows. There's all kinds of things that could go wrong. And we sort of aggregate all that risk into one number, and then we give you that expectation. And you basically don't have to worry about all those weird things that could go wrong. You just know this machine is going to be up 99.9% of the time. So
there's a whole bunch of these kind of edge cases, I guess, if you will, that are just handled because you're running a VM in a cloud, instead of on an individual physical machine. So we've got all of those. We've got these tools, like something similar is happening at the disk level. We've got load balancers that are, built out of lots of machines, kind of data center level things. We've got groups of VMs, like managed instance groups, and then like zones and regions and all this kind of stuff. But then I don't know, like then some of it, like it's to the app kind of level problem, right?
Like you're saying you want to design an application that can handle this 40 minutes of downtime a year too as well. That's interesting.
Yeah. So, okay. So we get to the point where we can trust the VMs and then kind of build from there, I guess.
Yeah. The important point is to kind of know what level of trust you can put into the VM. And what you're really doing is you're putting that trust into the hands of your cloud provider. And you're saying like, look, just tell me what it's going to be. And like on GCP for our VMs, we tell you it's going to be 99.9 for one VM in one zone. And then it just means that you get to put all that out of your mind, and you can trust that number is going to be true. And now you have to work around it. It's important that you don't think that number is, it's close enough to 100. Let's just say it's 100%, because like that's not true. Like if you make a distinction between 9.9 and 100, you're going to make actually radically different design choices in your application. You're going to start to introduce things like retries, or you're going to introduce things like checkpointing, or you're going to like allow your service to potentially live in two places at the same time. Like what if one request comes in here and one request comes in there, and like this one's up and this one's not. Like now that you've allowed a little bit of failure into your understanding of the model, you change the way you think about designing your system. And that was actually, like, to me, that was one of the fundamental things that made Google succeed from the very beginning, was that we designed our systems to allow some form of failure. And then we just added that resiliency over and over and over again, all the way through the stack.
This is so interesting because the way you just worded that, it finally made it click for me. By planning for failure, it doesn't matter what the failure is, because I have the case covered. It's going to be some delay to getting this information to me in some way, so I'll retry it. I'll do something like that. And then that allows you to build more resilience and reliability. Again, it's an abstraction away from the core thing. I don't care why it's down. Let me abstract. To put it in a real world, there's some important use cases where this matters, and that's why there's so much effort going into this thought.
That's right. It's important to not try to get the highest level of reliability out of absolutely everything, because you're going to have some, websites or services or whatever that like can be down. It's no big deal. It's not a problem. But like there are other services which are actually really important. So let's say there's a service out there that like responds when someone needs to like get a new delivery of oxygen tanks to some, medical center or something like that. Like we should probably make sure that one works, like most of the time. And even if like you make a request and like it doesn't work right away, but we know that like once we put it in, like it, was received and like someone will take action on it or something like that. Like that's just kind of a silly example, but like there are more and more of these services that are becoming more and more important to the world, because frankly, we're just putting more of our society online. So I think COVID is actually an interesting time to go through this whole like reliability effort, because we saw a lot of services became more and more important to individuals, like in an accelerated kind of way. Like it was already getting more important, but during the last couple of years, it went like really steep. So think about video conferencing for school kids, or, just ordering things from home. Like being able to do this online is becoming more important. So making sure that you can do it when you want to do it is more of a big deal even than it used to be.
Yeah, things getting very real. Like more of our life goes online, like it matters more and more critical. So, okay, this has been amazing. I think we're going to have to wrap up this one, but I feel like there's a lot more to talk about here. And so, Steve, would you be up for coming back and talk specifically about when you decide, kind of what questions you ask, about whether you're going to try to get another 9, and then how do you actually do it?
Yeah, I think I can make it. That should be fine. I think this is an important thing. Like people really want to hear about this stuff. So I'd love to come back.
Hey, well, thank you so much,
Awesome.
Steve. Brian, thank you so much. If you're listening at home, please write in the comments if there's anything you've learned about reliability. I know I learned a few things. Maybe you did too. Thank you.